Good afternoon, good evening, one and all. Thanks for joining us in episode number 5 of the SRE Practitioner Series. Today, I have an esteemed guest and good friend, Rob, CEO and co-founder of RackN, joining us from Austin, Texas. Thanks, Rob, for taking some time today and sharing your views about the world of SRE practitioners. I hope you're doing well and staying safe.
Thank you. It's delightful to be here, and it's, I really appreciate that you're taking the time to have these conversations because there's so much going on in the field. Really exciting. So I'm looking forward to the questions.
Excellent. So Rob, give us a rundown of your journey and what you've been doing now as part of your company, and how is it related with SRE, because that's the whole episode focusing on. So we want to get a little bit of background and memory lane around what has been exciting about this whole SRE space.
It's funny. My first sort of drive to do SRE work was way back in my early consulting days, and I was running around a network trying to patch Microsoft Access databases, and it was insanely hard. And I said, this is for the birds. And I started doing web apps and web development because at least it was from a centralized server. Right. and I wouldn't have to run around to each system and patch the software every single time. And that mushroomed into building actually some of the very first cloud infrastructure anywhere. We installed VMware. We built a multi VMware server cloud, filed patents around it back in 2001. And I've been in love with doing, software for infrastructure ever since. RackN came out of work that we were doing in the early OpenStack and Hadoop days, where we were getting really frustrated by the fact that when we automated and delivered, code, Hadoop, OpenStack, other, cloud.com, Eucalyptus, into a customer site, the code, the automation that we built didn't age well. Right. And we couldn't patch, if we fix something, we couldn't patch the automation. We could patch the code, but we couldn't patch the automation. It was super hard. And so RackN was really built out of this idea of how can we make it so that when we build automation, that it's portable and reusable. And if we fix something, for one customer, then every customer can take that patch from an automation perspective. Like when we look at, and that's infrastructure as code to us, it's not about, can I check it into Git? It's actually, can I modularize and patch and reuse and collaborate around building the automation? That's what makes infrastructure as code work.
Excellent. So you talk a lot about complexity, right? And we know it is complex in a distributed environment that we manage. So what should people be thinking about complexity? I don't think we are going to get anywhere sooner to make it much more simplified. It's going to be a nightmare of having bimodal IT about something still being heterogeneous, monolithic, and then a bit of it. How do you manage to think about complexity?
Yeah, this is where I actually declare defeat. To me, the challenge with complexity, and we do a lot of bare metal work. And so when you're talking about bare metal, it is complex. You can't, just say, oh, I'm not going to put RAID cards into my servers, or I'm going to only have one NIC because that's easier. Right. You actually, there's reasons for the systems to have the complexity in it. So when we started doing automation, instead of trying to simplify and be, very opinionated, this is the only way to do it, what we did was we embraced the heterogeneity, we embraced the complexity. Right. And it's amazing how liberating that was, because when we did that, we said, okay, how do we manage the complexity? And so instead of looking at the fact that, everything has, all the hardware vendors have different models and all the models are different and the vendors are different, instead of looking at it as a defect, we thought about it as just a feature. It's not exactly a feature, but it's an attribute that you have to manage to. And so we spend the time to deal with heterogeneity in our systems, and we deal with state changing outside of our control, right? That's another classic piece. And we deal with the idea that you have to connect different pieces of automation together, right? Our customers want an end-to-end flow, turn on, boot a server, get working clusters out of the end, or I need a cluster, go build things out of the cloud, pull it in, do a whole bunch of configuration. So mixing configuration and provisioning and ticketing systems and identity and certificates, all that stuff has to get mixed together. It's not one thing, it's all different things. And so we look at that as a mixture of systems.
So kind of playing around with the theory of constraints, but also trying to look at things which are under our sphere of control and influence rather than just waiting and watching.
It's funny because we really do a good job at siloing teams together and saying, this is my thing, I know how to do it, get out of my way. And then we forget that as you build that system up, it might actually be adding complexity to everybody else around you, right? Theory of constraints is really good because it says, hey, I need to focus on my bottlenecks in the infrastructure. But you could build automation without thinking about what's upstream and downstream from you, and actually make the whole system more fragile. We see this all the time right now in cloud systems. One of the other things about complexity that I think is really fascinating is there's a lot of hidden complexity in cloud infrastructure today. What I actually think of as the Jevons paradox. Super cheap to add a service into your workflows or into your business or your code base.
Right.
Not even think about what's behind it. But you actually inherit the complexity that company deals with, right? Do they have a dependency on US East 1 that you weren't aware of?
Correct.
And so, when we're building systems out, it's super convenient to have an API that abstracts a whole bunch of complexity, and that lets me move faster and lets me build more complex stuff. But I might actually be paying a penalty without realizing it for assuming that that's a utility, or not having to worry about, did that service use Java?
Right.
Perhaps. Yeah, this month December has been really hard for SREs. Really, really hard for SREs.
Sure. And you seem to be excited about infrastructure as a code. And I look at this as part of your central nervous system. So why is that you get so excited about infrastructure as a code, and you have a different philosophy of looking at that element much more strongly? So tell us, our viewers, about that spin over, right? We have a lot of misconceptions, but I wanted to hear from you as to why you think it's so powerful.
So we've been doing infrastructure as code for a long time for RackN.
Right.
Because that mission of how do I distribute automation to a customer in a modular way? How do I decompose it so they can, they have reusable pieces? That was very code-like behavior. And I actually did some talks where I sort of built a pyramid of dependencies in infrastructure as code, starting with, I can put my code in Git as the very bottom level,
Right.
which a lot of people are like, that's the infrastructure as code, or it's in files. I can describe it, that declarative system. What we found is that you actually stack things on top of that, right? Dynamic infrastructure and being able to have API-driven things is important. Modularizing is important. Sharing state is important. And what we found in that analysis is the very top of it is actually a CI/CD system.
Right.
And there's when we look at code uses CI/CD infrastructure or CI/CD systems, what we call a CI/CD pipeline. But for infrastructure and automation, we're considering that an automation pipeline or an infrastructure pipeline.
Okay.
But to make all, that's the pinnacle. So you want to be able to say, this is what I want. I'm going to run a standardized process and I'm going to get to the end. We look at infrastructure as code as the only way to get there.
Right.
Because that pipeline shouldn't be custom. The pipeline can't be connected together. You can't say, oh, my ops team does this, right? It's just like we went through with CI/CD over the last couple of years.
Right.
We used to build, the developers would build the software and hand the binaries to test, and test would test the software and hand the binaries to production, and production would, and CI/CD pipelines are like, no, that's bad. We have to have a flow that goes through that system. We need to do the same thing with automation. And to me, infrastructure as code is actually applying that process into automation processes and the collaboration that goes with it and the cross-silo operations. The totally, it's just totally new way of looking at how we build automation.
Right. And in terms of most of the companies that we see who look at application modernization as a part of their journey map, find it a little difficult to look at where do they go with lift and shift, where they need to refactor, where they need to re-architect. So what would be your suggestion in terms of the application modernization? Because that's a very important tenet to make that SRE really work well. So what would be the best approach? Sometimes you get into analysis paralysis, you don't do a lot of things, you don't get anything done. So how do you make that shift towards moving some incremental improvements in the way to approach that?
Yeah, this is where you have to distinguish between complexity and coupling.
Right.
And also, I think that we have a tendency in architecture, and so this is a little bit of an aside, but it's a useful story. So we sort of see this pattern with all of our customers, and if you're an operator, you'll empathize with this. We show up, and they at some point they will drag our somebody aside from our team and say, look, I have a dirty secret about my operations. I had to do this
Yeah.
bad thing to make all this stuff work. And the funny thing is, it's always the same bad thing.
Right.
So, right. And you turn to them and you're like, everybody does that.
Yeah.
Nobody talks about it, but everybody does it because it's the limitations of the system.
Right.
And I think part of the lift and shift philosophy, especially from an ops and an SRE perspective, is you need to identify real coupling and work to fix it. And you also have to turn around and figure out things that are just the way they are, and adapt and accept it. So I think one of the mistakes people make is they look at that process and assume they have to change things or fix things that they might not have to change or fix.
Right.
So I think that ends up being a really big deal. And there was another point, and it slipped my mind now.
I think you're right. You're right in terms of looking at it. And the reason that the problem happens, Rob, is that there's a lot of pressure to move forward faster. So they want to get something on the board for an MVP part of it to do it. So there's a lot of challenge around this, playing around it. So as they start to transition, many of the organizations still struggle with commercial off-the-shelf products, right? If you look at your big monolithic ERP systems or SAP systems, they still have to live with that. So do you see that there's an opportunity for those monolithic applications to still become containers, to move towards microservices? Because it seems to be easy said than done. Again, the level of complexity plays into that whole underlying stream. So how do you think customers are looking at this whole episode, and what kind of approach are they taking into this journey?
Yeah, I do think there's a degree of assuming that you have to do everything with microservices and put it in containers, and that those are the answer.
Right.
And this comes back to embracing complexity and understanding heterogeneity. If you're going to spend a lot of time stuffing something in a container because you've decided that it has to be in a container because containers are the right answer, you're not, that's operators shouldn't think like that.
Right.
Operators, right? We see this with people who think, oh, I'm going to switch to an API driven something and it's going to solve all my problems.
Right.
Yeah, I mean, you want to look at things that can be put into those systems, but you have to understand what the benefit you're getting from it. You might never receive any benefit from stuffing something in the container, or it might make it more fragile and it can't deal with being stateless. So fight the battles that you can fight. Understand when you're making those things the right decision. That doesn't mean I don't like containers. Like we think we use containers for a lot of stuff, but this is a good example with RackN. RackN, we used to run our platform 2 generations ago in a whole bunch of microservices, right? So we split DHCP and provisioning and TFTP and file serving and web serving into separate containers and put it all behind a reverse proxy. And it was abysmal. It was expensive. It was hard to do. It was hard to troubleshoot.
Right.
We actually collapsed all of the services into a single Golang binary.
Yeah.
And so now there's one binary that does all those services. We didn't need to put them in containers. Actually, separating them made the intercommunication between those services harder. instead of putting them into the same system. And then once it was in a Golang binary, there was no reason to wrap it in a container because it's just a single binary. And we still have customers who show up and say, I only run things in containers.
Correct.
And we're like, okay, we get it, but you don't have to. And that's the decision they make. I mean, we see the same thing in Kubernetes, right? Kubernetes is a whole bunch of Golang binaries, and people put those in containers because they want to distribute containers, but they're really just, it's a systemd file and start it. You're not really gaining very much by packaging in a container. So
right,
you have to be careful.
And you also talk a lot about, in terms of zero-touch workflows. That's always been the magic wand. People are looking at, oh, I'll press the button, and after that, I don't need to worry about anything. Everything is deployed. So is that a kind of a misconception around the zero-touch automation or zero-touch workflow that you're talking about?
Oh my goodness, there is. It's really hard. I remember when I was at Dell having an executive pounding on the table and saying, I just want the easy button for installing of OpenStack. I just want the easy button for OpenStack. And the pounding on the table, like yelling at me, was going to make me pop an idea out of my head to make that happen. We need zero-touch workflows. It is critically important to be able to drive things end to end. But there's a lot of hurdles in that process, right? One of them is that you actually have to be aware that you're changing the context of the automation to do it. But people assume it's like one type of automation. What we found in experience is that automating a zero-touch workflow is going to touch a lot of systems, and it's going to be different types of automation. I have a short story. We were helping a customer. They want to improve the performance of, I think, there were Linux installs, but it was a bank. And so they were like, yes, just help us, we need to get this 4-hour process down to a 30-minute process. And so we showed up and they're like, okay, it's just these 3 things we have to do. But when we did those 3 things, we found out that it was actually connected to another system and connected to another system and connected to another system. And by the time we'd gotten the end-to-end process working, there were 10 different systems that had to be consulted into that. Right. The long straw was actually an AD, Active Directory registration, so that they could create their credentials. And that was taking an hour through their process. And so what we were able to do is start that process, do all the other work, and then come back and wait for that process to finish. And the fastest we could make it was that long pull process. Right. But when people are building these systems, they tend to think that they can get away without worrying about that, or that they can front load everything. Like, oh, I'm going to build an Ansible playbook that has all the things set, and I'm going to push go, and it's going to do the magic. What we know is that doing an end-to-end install or a process requires you to be ready to take data from all these different systems. Right. You just can't escape it. And it actually requires you to accept that you're not going to know things that you need to finish the process until the middle of the process. Sure. Certificates are the simplest one. You're going to build certificates for the systems. You can't build the certificates until you've gotten the IP address and the name and the system's running. Right. So to do an end-to-end process, you have to be ready to accept that you're going to have evolving state. You have to be willing to accept that you're going to have to pull information from other systems and bring it back. And that from us, our perspective, that's why we started calling this infrastructure pipeline. Because just like when you're building a code pipeline, you don't have the binaries until a mid-step, and you might not have some of your credentials or signing certificates until the next step down. And that stuff is evolving data that gets forwarded through the pipeline. And it's funny, people don't think of automation like that. And so it makes it hard to build an end-to-end system. When we describe it as a pipeline, it's sort of something clicks, and the mental framework suddenly makes things easier.
Right. So the other bigger problem that I see when we look at tools is there's a whole lot of tools. So tool chain becomes a nightmare, right? Yeah. Honestly, every time we go to client engagements, they have a whole set of new shiny tool that has been placed because they think that's a magic wand. It could be AppDynamics, Dynatrace, Prometheus, Grafana, all of those stuff. So sometimes are we overdoing this whole tool chain part of it? Is there a way that we can simplify this whole stack about it and try to take a step back and say, hey, you know what? Do we really need the whole set of things? So how do you approach for someone who's quite curious to bring in a stack of tools and hope that is the magic wand that will make it everything work?
Yeah, we do actually need the tools. This goes back to the embracing complexity
Right.
piece. Because it's just an innovation defense mechanism. If you start with the idea that you've selected the right tool for this job, and you don't, and then you're like, now I don't have to select any more tools, then you actually do end up with a problem of, yeah, I actually need a new tool, and you said I can't, or this is the old 1990s 2000 era IT department, no, a big no stamp, and that was super easy, no. So you have to be able to say yes to these tools. You also have to be good enough at using them that you can say, you know what, this overlaps 100% with this other thing, and so just you don't need this new tool. You have to. So it's a balance, yin and yang balance.
Right.
But the thing that we see is really problematic is when people take tools that are very productive at doing one thing, and because they have approval to use that tool and it's in their system, they then try to make it do something that it wasn't designed to do. Right, like Ansible doesn't do a good job of doing provisioning operations. It's clumsy. It's designed as a remote client. Terraform doesn't do configuration on machines very well because it's designed to do provisioning.
Sure.
And so the more people spend time trying to make a tool designed for a certain function do something else, the bumpier things get. And so our actual answer is, we're trying to glue together all these tools and then have them share data.
Sure.
And our frustration with the tools is a lot of the tools they're trying to own the universe and they're not designed to share data.
Sure.
And so you get this like, oh, no, you can't modify a Terraform state file if you find new information. It has to be done internally. That's a huge problem.
Correct.
To us, right? Terraform's great. It does amazing stuff. But if I need to make a change outside of that tool, which we always have to,
right,
then I don't have the tool doesn't expect that to happen.
Correct.
And so I would look at, if you're evaluating tools, look at tools that are good at interacting with things to the left and right of them in the infrastructure pipeline,
right,
and bias towards that. But yeah, you're not gonna, tool sprawl is real,
yeah.
And not inherently bad.
It's true. And my last final question would be, changing established systems, because many of the organizations have well-renowned systems that have been running in place. So don't touch it, everything is working well, just run as it goes on. So changing practices is becoming very hard, right? You get, tuned towards a way of working, this has worked for so long, so it'll continue to work, right? So how should people think about transforming, what they have and what they can, and that cultural shift and challenging the status quo and moving forward? Very easy said than done.
And this to me is actually one of the point that I wanted to bring up earlier, and I'm glad you came back around to this concept. You want to reward good patterns,
right?
And so the reality is that systems that are in place are doing work and they're useful, and they can be very hard to migrate away from because they're in place, right? You don't want to throw out working systems. You don't want to throw out working servers or cloud infrastructure. You might already have that piece, but, and this is the key, what you want to be doing is replacing systems that don't drive good behavior.
Right.
And this, we actually work really hard at this and think about it, is when, especially like infrastructure as code, if you have a system that makes it easy to hack and build a custom thing and not make it repeatable, then you want to try and eliminate those things from your infrastructure.
Sure.
Just if it's old and encourages good behavior, then okay. If it's old, but we see this like with old cobbler stuff. Every time people do cobbler, they're building custom stuff that only works for them. and doesn't have any reusability, what you want to do is bias towards systems that encourage collaboration and reuse and make it easier to, use good practices. Use immutable infrastructure and check things into Git and decompose something into a reusable piece. Or better yet, slowly, you might have a custom thing. You want to be in platforms and tools that slowly let you stop having the custom thing and move towards a standard thing.
Right.
Um, and that is a really important SRE philosophy, because we're trying to reduce toil. And so anytime you've got a system that is unique to you or custom to you, even if it's coded, this is where SREs go off the rails. They're like, well, I wrote this, it's code. I've won because I've coded this automation task. No, you have not won if you've coded automation that is unique to your team or your company that could have been made into or from reusable components. And so I really do think that when you look at transforming your systems, what you want to do is you want to find the ones that have easy lift to reusable pieces. I'll give you another concrete example. Most companies have their teams that do RAID and BIOS configuration, and they've written their own code that does RAID and BIOS configuration. I can't think of a ask in an organization that adds less value to the organization, right? You have to set it. You have to set RAID and BIOS if you're doing hardware, but having your own process for doing it, there is no commercial value. It's probably actually the opposite, because you're now bespoke and you might not be able to take a new vendor and fix, switch vendors or take the new latest version because you've written all this code. So you have to be stamping that stuff out and looking at those opportunities. Just because it's old doesn't mean it's bad.
Right. Thank you so much, Rob, for your time. And I'm sure that we can talk for hours for this one, probably in a later episode. But thank you so much for sharing your deep side views around SRE and for practitioners, because we hope that it inspires more people to understand practicality, right? I mean, you need to have that level of acumen to distinguish between the Googles of the world to what is reality for your own companies, right? And I hope that this will be valuable. Thanks for your time today, and we'll stay connected.
I appreciate it. It's always fun to share some war stories and help people can learn some of the lessons and avoid the traps. So
Sure.
thanks.
Thank you so much.